In the previous video, we looked at a basic definition of thermal expansion. Now we're going to look at how we can calculate the amount of thermal expansion in solids. In solids, we will only be looking at the change in length of one dimension of the solid. This is equal to alpha, which is the coefficient of linear expansion, given in this table, multiplied by the original length, multiplied by the change in temperature. It does not matter what your unit for length is, as long as you make sure and carry that label over to the change in length. In other words, delta L is equal to alpha times L times delta T. In the table, we can see the coefficients of thermal expansion for some common materials. Thermal expansion in solids is a very useful property. If you are changing your brakes and your brake rotors are stuck, typically people tend to heat them up because they expand, and this expansion causes the rust to break apart because the metal it is surrounding has expanded. This makes it much easier to beat on the brake rotors to get them off if they are stuck. Let's take a look at an example of finding the change in length. A steel railroad rail is 40 feet long at 0 degrees Fahrenheit. How much will it expand when heated to 100 degrees Fahrenheit? First, the equation we need to use for the change in length is delta L equals alpha multiplied by the length L multiplied by delta T. The value for alpha, or the coefficient of linear expansion, is 6.5 times 10 to the minus 6 per degrees Fahrenheit. The length is 40 feet, and the change in temperature is 100 degrees minus 0 degrees, or 100 degrees Fahrenheit. Multiplying this together, we see the change in length is 0.026 feet. However, it is kind of hard to picture exactly how far 0.026 feet is, so we can convert that into inches. So we actually have 0.312 inches. This concludes our discussion of thermal expansion in solids.